How's everyone doing? You're back with your boy Jono for another quick math lesson. Today we're going to look at something completely different to what we've been doing on this channel and switch from maths to a little bit of science. So today in this lesson we are looking at Punnett squares, and this is a tool that we can use to correctly predict the possible genotypes or the possible traits that offspring will have based on what genotypes that their parents have. If you can prepare correctly for this topic, there is no way that you can make a mistake. Preparing properly is the only skill you need to learn, because once you've got it down on the paper in front of you, I guarantee you're going to find it pretty cruisy. So the first step that you always have to do is you need to write down the traits that are going to be assessed in the question. So it doesn't matter what you're looking at, you can always give a letter based on the traits available. So for this example here, we've got red eyes and white eyes for some creature. If I say that the capital R is red eyes, or the dominant allele is red, I need to say that the recessive gene is that lowercase r as well. Please always write this down. Sometimes it's going to be in the question, but I want you to write it down anywhere, somewhere that's really available for you to see, so you can just refer back to it all the time. If you do this, I guarantee you're going to find that next step really easy. So writing it down in the question straight away, assigning a letter to the gene that you're looking at, is the first step to get these fully correct. The second thing that I want you to do is to highlight the parents' genotypes and then write these down. Sometimes you might be given the actual genotype. It might be, big R, and big R, little r. But that's not always going to be the case. Sometimes you're going to be told information about the parents, and from that information, you've got to work out what the genotype's going to be. So for example, in this one, it could be that the mother is dominant homozygous and that the father has white eyes. So for that first one, I want you to highlight the word homozygous dominant and then write mum equals big R, and that's all you need to do. Because we know that the dominant allele is red eyes for this, or that capital R, because dad's got white eyes, he must be homozygous recessive. So just write that dad is equal to little r. This is incredibly important. If you miss this first step, it makes it much harder to see what actually goes onto your Punnett square. In some questions, you're not going to be given a scaffold, you're going to have to draw it all from scratch. All you need to do to make sure your Punnett square is correct is just draw a really quick noughts and crosses grid and then just put a square around the outside. So just remember that top left cell is not used. I sometimes actually black it out so I don't forget which one I'm not using. So all you need to do to get these down on the paper really quickly is draw our noughts and crosses board and then black out that top left cell. So now we've got the Punnett square and we've got our parents' genotypes. All we need to do is put these on the outside of our Punnett squares. Just remember that on the outside, we just have one letter per box. That's incredibly important. I actually still like to write mum and dad on my Punnett square just to make sure that I'm not getting confused, but you definitely don't need to do that. From here, I've got my mum is big R, and dad's little r, and now we've got all the information we need onto our Punnett square. Again, just remembering it's that one letter per box on the outside. Sometimes my students put mum's genotype, big R, in one box, and then we get really confused. So just one letter on the outside and you're good to go. Now we've done all the hard steps. To finish off the Punnett square, you just have to connect the row and the column and write down what you see. So for all of these, they're going to be big R, little r. So that means that we've got all the information incredibly easily. You don't have to do any thinking if you get those first steps right. Remember, the preparation is the most important step. Then you just got to answer questions based on the information in the middle of your square. So for this one, it's actually incredibly easy. We've got a 100% chance that all offspring are going to be heterozygous. Every single one of the offsprings is big R, little r. And because our genotype is 100% heterozygous, it means that our phenotype, 100% of these individuals are going to have red eyes. None of them are going to be homozygous dominant or homozygous recessive. They're all heterozygous, which means that dominant allele, the big R, wins out, and we've got all red-eye offsprings. So an exam style question could be something like this. We've got that P's are tall or short, and being tall is a dominant gene. The first thing that we have to do is assign letters to being tall and being short. For this, I'm going to use T for tall. So capital T is equal to tall and lowercase t is equal to short. If you use H for height, that's totally fine, but you have to assign a letter to tell the marker what you're actually looking at. From here, the information that we need to know is that a short offspring is made, we need to see a recessive little t in our offspring. If this is not possible, then we know that the question is not correct. But we're saying here we've got 2 tall plants and a short offspring. How can this happen? Because we're looking for little t, or a recessive trait that is shown, we know that both the parents, which are both tall, have to be heterozygous. They have to be big T, mum and dad. If either of these are dominant homozygous, so big T, there is no way that we could get a recessive allele. So because I've assigned a letter to each of the traits, and I've said that mum and dad are both heterozygous, that's all the information I need. All I've got to do is throw it into my Punnett square, and I'm definitely going to get the right answer. So mum's big T, and dad's big T, so I'm putting them on the sides. Now I just have to do my cross, and I've got big T, 2 heterozygous, and 1 little t. From here, I can see straight away that these 3 green ones, with the dominant allele, they're all going to be tall pea plants. But I've got 25% chance, or one of them, that's going to be a short king. Because of that, I can say for sure, with 2 tall parents, I could have a short offspring. One of the big leaps that students do find difficult in this question is to be like, oh, well, how did you know that mum and dad were both heterozygous? We're just going to make a Punnett square to see why it has to be like this. If either mum or dad was dominant tall, so big T, and we still made our Punnett square, we could see that those big T dominant alleles would go into every one of the offspring. Here in this Punnett square, we've got 4 tall offspring, and that's not what the question's looking for. So because of this, I knew that mum and dad had to be heterozygous. It's the only way that it could have happened. So if we go back to our heterozygous cross, all you have to write for your answer, you've shown all the working, is that, hey, there's a 25% chance that the offspring of 2 tall heterozygous plants are going to be short. And that's kind of your final answer. The phenotype's short because we've got recessive genes, done. So I do know that there's a lot of terminology in this lesson. And if you're not on top of the terminology, you do have to spend a little bit of time making sure you've got it 100% down. I guarantee you, once you got the words down, you're going to find the marks from the Punnett square incredibly easy to get. As long as we prepare correctly, the questions are just, hey, read off this table that you already made. Thanks so much for watching, guys, and I'll see you later.